Okay, so this is a very long introduction to the titration maths. I'm going to use, obviously, titration 1 because it's the first one we did, and I will make a shorter video showing you kind of what you would do. But this is kind of going to give you the background to the maths. So the points that I really want you to note are here. You are going to do this in the extra pages in the back of your exam. You're going to have to look back through a question and through previous answers within that question to find the information you need. So this is what you are doing in the back of your paper. You're going to find the equation for yourself. Now, there's a possibility that they will ask you to finish it and balance it. So if it looked like this, again, you have to be aware that this and this, or firstly, you should be aware that this is an all boys sing well bonus. So you're going making a salt and water and CO2. And it's the things in the red circles that are going to make your water and that are going to make your the carbon dioxide. So we have our arrow. We know that we're going to be making H2O. I don't know why it keeps doing this now. So H2O, and you know you're going to be making CO2. So because I have H2O, I need to have two H's here, definitely. And the things that are not circled in red are going to make my salt. And you just need to make sure that you are writing the correct formula for your salt. So you need to recognize that sodium is a +1, chlorine is a 1-, and that this is a 1:1 ratio. So that's my formula for sodium chloride. And because I have this number 2 here and this number 2 here, that it's going to be 2 NaCl. Now, when we're doing our titration data table, we are only interested in these ratios. So even though there is nothing written down, we know that it's going to be 1 sodium carbonate. So you will have your balanced equation because we want these ratios in our table. So you are going to, as I say, be drawing this table at the back of your the lined paper in the back of your exam questions. You are going to write attic and basement. You are going to have to see, can you find of the volume that we're interested in, a concentration and an N value. So in the attic, it's normally the thing that's in the burette, and it's going to be the weird number. So not a perfect 0.0 number, it's going to be something weird. The base is going to be the thing that was measured out with the pipette. So when you're reading the blurb, you know, you can look for that. And it's going to be a perfect volume. So it's going to be something 25.0 perfect, whole number, nothing in the decimals. So in our first titration, when we did this, or the example that I'm going to use, we had 25 centimeters cubed of the sodium carbonate in the base. You had done the maths, so it was a 0.1 big M, and the ratio for my carbonate is going to be 1. For the other one, you will have your own titer value. I'm going to use this one. So see, it's 0.2. That's kind of a weird number. This is going to be the end point for our titration, and the ratio here is 2 HCl. So the things that they can ask you to do will be a whole variety of different things. But I'm just going to go through the maths from start to finish. So for us, from start to finish, we are looking for the concentration of what was in our burette in terms of big M and in terms of grams per litre. So you are going to be using this type of shape, and at each point on this, it means something. And you set this up using your table, the information in your table. So back up here, it is this portion here. I call this the way in to our titration maths. And what you are going to have is the idea that this is going to be 0.1 big M, and it's going to be the sodium carbonate. So in this W, everything we do on this left-hand side of this vertical line is going to be to do with sodium carbonate, and everything, when we're finished over here, it'll be a big M value for HCl. And this is giving us the steps for the maths. And you are literally following this path to get to the end. So in simple terms, we have these labels on our points. This is going to be moles per centimetre cubed. This is going to be moles in our titer volume for our sodium carbonate. This is going to be moles for our titer volume for our HCl. We are going to apply our ratio here. Following along, we will have moles per centimetre cubed here. And finally, when we go up to the top, this is the thing that we're trying to find, the question mark. So just referring back to the data table, by the time we are done, we will have used every number in this table to find that question mark. Okay. In a question, they will have, moles at the end point. That's going to be their blurb in the question. Okay, so I'm going to just scroll again, and now we are going to, maybe I'll put it over here so you will be able to see the data table at the same time. So this is going to be our steps. So again, we have this big W that we are interested in making, and we're going to fill it in with what we know. So we had said that 0.1 big M, and you are going to expand this to explain what it means. And it means 0.1 moles in 1,000. Okay, that is not as big as I'd like, so I'm going to get rid of this. And I am just going to make this a little broader. Nope, still don't like that. Apologies. Nope, did not like that, does it? So we're going to make it. So we have the 0.1 moles. When we go down, any going down in this triangle, so we go down here and we go down here, they are all going to be divisions. And we're going from moles in 1,000 to moles in a centimetre cubed. So I am going to be dividing by 1,000 every time on this portion. So it's going to be 0.1 in this case, divided by 1,000. And when I do that, I am going to get 1 by 10 to the minus 4 moles in a centimetre cubed of our sodium carbonate. Okay. So every time we go up in this, and we have two scenarios here, we're going to be multiplying by something. And what we're trying to find up here is moles at our end point, which in this case is going to be the moles per 25 centimetres cubed. So you can see now over here, I've used this 0.1 and I'm now using this 25 centimetres cubed. Okay, so they have now disappeared. I'm just going to get rid of them here so you can see them. So here I'm going to have to multiply my 1 by 10 to the minus 4. Essentially I'm multiplying by 25. So when I do that and put that into my calculator, I'm going to get 2.5 by 10. I hate the AI keeps coming in. No, go away. It's really annoying. 8 by, no, it doesn't want to write at all, does it? Does not want to write. Okay, we got it back. So it's 2.5 by 10 to the minus 3 moles, and that's in 25 centimetres cubed. Okay, so at this point we're going to use our ratio, and our ratio here is our 1 is to 2. So 1 equivalent is 2.5 by 10 to the minus 3. So to flip it to the other side, and remember this is the HCl side, I'm going to just double it. So it's going to be 5 by 10 5 by 10 to the minus 3 moles, and that is going to be in the 40.2 centimeters cubed. Okay, I'm really going to scream now. 40.2 centimeters cubed. So now I know how many moles at my end point of Na2CO3 and of HCl. So we're going down again, and we know it's going to be a division, and we know that the answer we want, the final answer, is going to be moles in a centimetre cubed. So to do that, I'm going to divide by my titer volume, which is the 40.2 centimetres. And so it's going to be 5 by 10 to the minus 3 all over 40.5, or 40.2, apologies. And when I do that, the answer I'm going to get is 1.244 by 10 to the minus 4. Now, the previous answers, I didn't have 4 significant figures, but if you can get 4 significant figures, you're going to put them in. Okay, we're going up again, and we're trying to get to the big M value. So I'm now going to multiply by 1,000 centimeters cubed. Okay, and when I do that, I'm going to get 0.1244 big M HCl. Okay, so that's what we call final answer for something. But we've gone for our titration maths, we've converted it to a big M value, whereas all we had over here was the question mark. So at this point now, we have used every number to find our question mark here. There's one other piece that you're going to do for me now, and that is when they ask you for concentration in grams per litre. So this is using our conversion factors. So we know we have moles, we know we want grams, and every time we want grams, you have to be thinking that you have to do an MR calculation. So I have 0.1244 big M. I've got to do a little molar mass calculation now, and it's the HCl is what I'm trying to find out. So it's 0.1008, and my Cl is 35.45. And when I put those together, I get 36.458. I want 4 significant figures, so that's the same as saying 36.46. So this is grams per mole. To get rid of moles, I need to have, and to make sure I end up with grams, my conversion factor is going to be flipped this way. Okay, so I've now gotten rid of the mole part of this. I've gotten rid of this. I put it into my calculator, and for 4 significant figures, it's going to give me 4.536 grams. So technically, in old Leaving Cert, this is a final answer, and this is a final answer, but we're not in old Leaving Cert. So you're going to have done this at the back of your book. You are going to be reading through the questions, and you are going to have to recognize, what the questions are asking you. So this might be the type of questions that you are going to get. The first thing they might ask you is find moles of your sodium carbonate in 1 centimetre cubed. And you are going to go back to your W, and you're going to have a look around, and this is that answer. And back in whatever box it is, you are going to write that answer in 1 by 10 to the minus 4 moles in a centimetre cubed, and you're going to go and say see extra pages. So what that is giving them is what was your start and what was your end, in case the new chief examiner wants to see details of your maths. The next question that normally would be a logical follow-on from it is find moles of Na2CO3 at the end point. Okay, and you've found that already. So when you go back into your thing, then that's this little portion up here. That is my moles of sodium carbonate at my end point. So you go back to wherever it says the question, and you are going to write in your answer. So 2.5 by 10 to the minus 3 moles per 25 centimeters cubed, and you're going to write see extra pages. So now we're telling them where they can find their answers. The next question that it might be asked might be find moles of HCl at your endpoint. So that's where we used our ratio. So when we have a look at our W, that portion is now over here. So again, we go back to where the question is in the book. And we type in 5 by 10 to the minus 3 moles in 40.2 centimeters cubed. And we also write C extra pages. The next question they might ask, hopefully you might be able to predict it, is find moles of HCl in 1 centimeter cubed. So again, we have a look back at our W, and this is moles of HCl in 1 centimeter cubed. We go back to the pages in the question and we write that in for ourselves. So it's going to be 1.244, as in 4 significant figures, by 10 to the minus 4 moles in a centimeter cubed. My predictor I'm going to write next. See extra pages. They might ask you to find the concentration of HCl in big M. So again, as we said back here, this is this red up the top. So you just put it in 0.1244 big M. And again, see extra pages. So they're going to go back and they can see how you got there. There may be a question that says find concentration of HCl in grams per litre. So this is our conversion factor piece of maths. So this is this one here. So you're going to go back to where the question is. You're going to go 4.536 grams per litre, see extra pages. Now, there's also a possibility. So you need to recognize what our W is telling you. So what are each of the points in each of the setups? There is a possibility that they could skip to the end. So they could just ask you big M, concentration of HCl in big M, and you have to be able to go and find it. So you just do this big W maths in your extra pages and you have to write in your answer. But it's really, really important that you can see the steps. The number of times I would have candidates that they would have answered this part and then they get completely thrown by this one and they like start doing their maths again for this and they kind of do something different because they kind of feel unsure. So the W is going to give you your template for all of your different steps, and you just have to be aware of what are each of these points. What are they? What are they telling me? What's going on? So really, really important that you do that. You might decide, you know what, I'm going to write basement over here and I'm going to write attic over here, or I'm going to write the name of what it is, but you have to put your knowledge onto it. And these are the type of questions that they're going to ask. So the only caveat that I have for you for all of these is you need to make sure that you are moving the right number from the back pages into the section for the answer, to your answer box. And that is the long-winded introduction to